Okay, so I'm going to try and rush through this test. This is going to be an explanation of the TMSCA test 10 from this year, math test. So, okay, question 1. So, got $567.89 in the account. So wants to spend a third of it. Buying ice cream, half the kids want that. Okay. So we'd be saying we have this amount. We want to spend a third of it, so this over 3. We're going to set that, well, first equal to this tax rate times. Okay, so let's call x the amount of kids in the neighborhood. So half want it at, well, they want the $2.99 ice cream. The other half want the $3.49 ice cream. Okay, so if we type that into our solver, then we get an answer of about 53.97. So that comes out to about 54. So that's our answer. All right, so then I erase this. Okay, question 2. So we have Jake recently purchased a membership. Here the monthly cost is $20. Okay, so what's his annual cost? So if the monthly cost of membership is 20, we gotta multiply that by 12. And he does not have his own shoes, so he rents a pair for $3 each time he visits. So we're gonna add $3, and he visits 7 times a month for 12 months. So then we're just gonna add these products together. And we get 492. So that's his annual cost. All right, so now we got a graph question. So this one's going to be for the next 4 questions. So we've got these points A, B, and C, and we got this line AB. Okay. So the line parallel to AB that passes through C. So which one of these is also on the line? Okay, so we want to construct a line that's like parallel, passing through C. Okay, so whenever I have to construct a an equation given a point, I always like to use point-slip form, which I use in the form y equals m times x minus x1 plus y1. Okay, so our m, because it's going to be parallel, this slope is going to be the same as the slope in line AB. And so if we look here, so we could see it goes down 3 for each 4 it goes across. So its slope is going to be negative 3 over 4. Okay, so now we're going to plug in the coordinates of point C, which are 3, comma 4. So we're going to do x minus 3 plus 4. And so this is the equation of that line passing through C that's parallel to line AB. And so we can plug in each of these answers into here, see what we'd get. So if I plug in negative 21, then I would get like, I think 22. if I plug in negative 9, I'd get negative 12, 3, positive 3. I'd get 13, so that's not right. If I try 19, then I get 16 over 4 is 4, times negative 3 is negative 12, plus 4 is 8, negative 8. So that's going to be our answer. Okay, so next question. The perpendicular bisector to segment BC intersects AB at coordinate G, H. Evaluate what G plus H is. Okay, so perpendicular bisector. So the way that's going to be constructed, perpendicular bisector of this segment here. It's going to look like that. So what that means for it to be a perpendicular bisector, so to bisect something, it cuts it in half. So this bisector is going to contain the midpoint of segment BC, and also the slope is going to be perpendicular to the slope of segment BC. So we're going to first get the, okay, well, first we're going to do, of course, point slope form again. And for the coordinates that we're going to use the coordinates of the midpoint. So let's calculate the midpoint's coordinates. So this point we already established was 3, 4, and B is 6, negative 4. So the midpoint, so I'm going to write that here, midpoint is equal to 4.5, 0. Okay. We can also get the slope of segment BC using this. So it goes down 8 and it goes 3 across. So the slope of segment BC is negative 8 over 3. So that means that if we do the negative reciprocal to get the perpendicular slope, we'd get 3/8 as our slope for the perpendicular bisector. So now I can plug that all in here. And plus 0, so, I won't write anything there. So this is our equation. And it's going to intersect with line AB. So let's write the equation of line AB. So if we look at this, so it goes down 6, I believe. So it goes down 6 and goes across 8. So its slope is going to be negative 6 over 8, or negative 3/4. I'm going to do point slope form again. I'm going to choose point A to work with, but it doesn't matter you can use any point on this line. The equation will still be correct. I'm going to pick point A. So that's negative 2, 2. So x minus negative 2 plus 2. Okay, so I'm going to just add a little subscript here. This is the AB, and this is the perpendicular bisector of BC. I don't know. I'll add like this little perpendicular sign here just to signify that. And so we want to find the point G, H where they intersect. So I'm going to set these two equations equal to each other. I'm going to use nsolve on my TI-nspire to figure out the x-coordinate where they intersect. So I will say this. You do not want to do this kind of question on the graphs page and look for the intersection, because it won't give you like the digits up to like the hundredths place. So it won't be precise enough to get the answer. So you have to do this on the calculator page. So I'm going to go into nsolve. I'll write this equation out. And so after typing it, I get that the x-coordinate where they intersect is 1.9444 repeating. And so if I plug that x coordinate back into the equation, I get that the y coordinate is negative 0.958335. I just added like it's like 0.333 repeating. My bad. Anyways, so now that we got their coordinates, we want to add them. So it's like 1.94444 plus negative 0.958333 comes out to this answer choice B, about 0.986. So that's our answer. All right, so question 5. So consider D comma, or D parentheses x comma y in the second quadrant such that ABCD is a parallelogram. So evaluate x times y. Okay, so this is not too bad of a question. So the way you want to think about it is with parallelograms, like if I have these points on the vertices, you see how if I choose to look at these two pairs, it seems to go down, like, let's say it goes down 1 and across like 7. Well, then the same will be true of these top two. So it would be going down 1 and across 7. And so we're going to use that strategy to our benefit here. So I could do this. I can look at these 2 points right here, A, B. I can notice if I'm going from B to A, I would have to go to the left 8. So I'm going to do minus 8. And I'd have to go up 6. And so I would do the same thing with my point C to get this point D somewhere up here. So the coordinates of C are 3, 4. So I'm going to subtract 6 from the x and go up, or subtract 8 from the x, go up 6 on the y. So I get negative 5, 10. So that's my coordinate for point D. I get the product here, and I get negative 50. So that's our answer. And the last question involving this kind of graph here. What's the shortest distance from point C to line AB? Okay, this is an important formula to know. So I would write this down if you don't already have this memorized. So whenever you have some line and some point, you want to know the shortest distance from the point to the line, this is the equation you use. So if this is like x1 comma y1, and if this equation is expressed as ax plus by equals c, so, like in standard form, then the equation of the shortest distance, so shortest distance is going to be the absolute value of ax1 plus by1 minus c over the square root of a squared plus b squared. Okay, so we've got a formula, but now we need to get a few things. So one, we need to get the coordinates of point C. It's pretty easy to do. So that's 3, 4. Okay, so now we got x1 and y1. But now we need a and b and c. So we've got to express line AB in standard form. Now I believe we had written earlier that the equation was going to be negative 3/4 times x minus negative 2 plus 2 when we were using point slope form. But now we need to change this equation from point slope form into standard form. So we could do that by distributing this value. Be negative, so distributing here and here. This is the same as adding 2. So this minus 6/4 plus 2. We could write 2 as 8/4. So then we can combine these. And that would be, whoop, that would be 1/2. So plus 1/2. So like that. This is all equal to y. So if I multiply everything by 4, I would get everything into whole numbers. I could move this to the other side, and so I'd get 3x plus 4y equals 2. And there we go. I've got my a, my b, and my c. So now we can use this formula. So I have 3 times, and x1 was 3, 4. So, okay. So 3 times 3 plus 4 times 4, and we're going to subtract 2, all over the square root of 3 squared plus 4 squared. So I believe this should come out to 23/5, which is 4.6. So that's our answer. So make sure that you know this formula. Very important. You see this kind of question a lot in the math tests. So moving on to question 7. If the point that is 4/7 of the way from A to 9 is 12 1/4, what is the value of A? All right. So if we kind of think about this like on a number line, 3/4 of the way from A to 9 is that. Okay, so we'd have like 9 is here. We'd have A be somewhere over here. And if it's 4/7 away from A to 9, so that means this distance, like here, well, this distance here is 4/7 of the distance. So what we could say, we can write an equation. We could say that A minus 9 times 4/7, that is the length of this distance right here. If I subtract that distance from A, then I'd be left with 12 1/4. And so I can solve for A. I can plug this into my solver. And so I'd get a value of A as 16.583 repeating. And so this part is equivalent to 7/12. So our answer is 16 7/12, which is E. So question 8. Question 8 says, the value of a gold coin has experienced an annual value increase of approximately 7.35% each year. If a coin purchased in 1976 is currently worth that much in the year 2024, what was the initial value of the coin? So this is a pretty easy question. So it's like we're saying x times, and if it's increasing by 7.35% each year, it means we're multiplying by 1.0735 each year. How many years? It would be the power of the difference between 2024 and 1976. And that this value is equal to the current value. So all we'll do to solve for x is just divide this by the annual rate raised to the power of the difference between the years. And so if you type that out, you end up with 49.99. Well, on my end, it comes out to like 49.999873. So that's pretty much $50. And so that's our answer. So pretty easy question. So that's all of the first page. Moving on to page 2. Okay, so for question 9, we've got the number of ice cream sandwiches an ice cream truck sells in a month varies directly. Okay, so let's say number of ice cream sandwiches varies directly. So that's K times, so like some constant times, the average temperature, so T average. And inversely, so we gotta divide by the price of an ice cream sandwich. So like that. Okay. So in June, okay, so it's giving us these values. The average temperature was 96 degrees Fahrenheit. The price of each ice cream sandwich was $3.50. And the price was 2,137. I mean, not price, that was the number. Okay, so with that, we can solve what our constant is, our K. And so our K comes out to 77.91. Okay, and so now it gives us these figures for July. So for the average temperature, let me just fill in my constant here. My average temperature is 89 degrees Fahrenheit. And we're going to reduce the price of each sandwich to 3.25. We want to know what the revenue is. So the way we'll calculate the revenue is first we need to find the number of ice cream sandwiches. So that would be calculated by doing this calculation. So if we run the numbers, we get 2,349.826. But remember, we're talking about like ice cream sandwiches. You can't have like 0.286 of an ice cream sandwich. So we're going to round down. So we're going to ignore that. We're going to say we have 2,349 ice cream sandwiches. And we're going to take this value, we're going to multiply it by the price. So that would be 3.25. And so that comes out to answer choice D, $7,634.25. Okay, so now we're on the 10th problem. We're going to be summing, we're going to be summing 4 consecutive positive odd integers. Gives us the product. What's the sum of these integers? That's pretty easy, so we can just type this in our solver. can write this number. We're going to set it equal to x times x plus 2 times x plus 4. I'm separating these by like increments of 2 because, that's how odd numbers are separated. Like that, for example. So these would be our 4 integers. And so if we type that into our solver, we get x is equal to either negative 97 or 91. And again, we're talking about positive odd integers, so we're going to ignore that negative answer that the solver gives us. We're going to say x is 91. We want to know what the sum of these are. So 91, 93, 95, 97. That's going to sum to 376. So answer choice D. That's a pretty easy question. Okay, so question 11. So Eric is riding his electric unicycle through campus. The diameter is given as 14.5 inches. So we know the wheel is rotating this many times per minute. We want to know what speed he's traveling at in miles per hour. Okay, so this value here, the 515 rotations per minute. So rotations per minute. Okay, so if we want to get to miles per hour, here's what we'll do. So there's 60 minutes in an hour. So to convert from rotations per minute to rotations per hour, we're going to multiply by 60. And so that would get us 30,900 rotations per hour. Sorry if I'm clearing my throat a lot. I'm a bit sick. But yeah, 30,900 rotations per hour. Okay, but we want miles per hour. So how do I get from rotations to miles? Well, I know that for every one rotation, I can convert this value. For every one rotation, that's one circumference length, right? So that's going to be 14.5 pi inches, right? And so if I multiply by 14.5 pi, I'll get, is that like 1.407 like 6 times 10 to the 6th power inches per hour. So the last step I'll do here is I want to convert inches to hour to miles per hour. So I can divide by 12 because I know for every 12 inches I have 1 foot. And then divide by 5280 because I know there's 5280 feet for every 1 mile. So after doing that, I'm left with 22.2 miles per hour as my answer. So the answer choice C. All right. Okay, so now we got another graph question. So, okay, for number 12 and 13. Okay, so we want to evaluate f of 90 minus f of 88. Okay, so this kind of graph right here is very similar to the graph of the square root of x. And so I'm guessing this is like some transformation of that graph. So typically, after the first point, okay, so here's how I think it's transformed. So I think it's like y times, I think it's like a, some a times like x minus b plus c. Something like that, right? It's gonna have like a horizontal translation, a vertical translation, and some elongation or like a squishing factor. And so how I can tell each of these things, so typically for the square root graph, it's like 0, 0, 1, 1, and like 4, 2. So typically, if the constant right here and where the a value is, if that's 1, then after going from the beginning and then going 1 across, I should go 1 up. But here, if I go 1 across, I go 2 up. And so that's a sign that my a is going to be 2. And as far as the horizontal and vertical translation goes, I mean, that's pretty easy to solve for. The beginning here, so typically, it's centered at 0. It starts at 0, 0, like the traditional square root of x. But in this graph, it starts at -1 comma -3. So that means my b is -1, so minus -1 here, and minus 3 on the outside. Well, this is 2. Okay, so my b is -1, this is -3. So my final equation is 2 times x minus -1, which I'll just rewrite as x plus 1. So 2 times square root of x plus 1 minus 3. And so now that I got my equation, I can plug in 90 and 88 and get the difference. So after doing that, I get a difference of 2.11. So that's my answer. And so I'm not going to clear this equation yet because I think we need it for question 13, which says, what's the average rate of change on the interval from 1 to 9? And so when it's asking for average rate of change, all it's saying is like, what's the slope of like the point where you connect like the point at 1 to the point at 9. So just what's the slope? That's pretty easy. We'll just do y2 minus y1 over x2 minus x1. And so that means we're doing f of 9 minus f of 1 over 9 minus 1. And so if I plug that in, I get a value of about 0.437. So that would be 0.44, which is D. That's our answer. Right, so it's another graph question, like from the first page, but yeah, not too bad. Okay, so number 14, an equilateral triangle. So let's draw that. Something like this. Has a perimeter of 40. Okay, so each side length is 40 over 3. Okay. At one of the vertices, so let's just pick this top one. One of the vertices of the triangle is the center of a circle with radius 4 units. So it'd be something like that. Has a radius of 4. What is the area of the union of the two shapes? Okay, so basically what that means when it's asking for a union is it wants to know like the area with like no extra overlap. So it's like, what's the area of like this shape? Okay, so we could do here is we can get the area of the equilateral triangle, and we could add it to like this remaining fraction of the circle. And so this is actually going to be a 5/6 of a circle. And the reason I know that is because, again, if I redraw this angle right here, where the center of the circle is, this is 60 because it's an equilateral triangle. So that means this fraction of the circle is 60 out of 360, or 1/6, meaning that all the rest of the part that like remains is 5/6. Okay, so we're just going to add the areas of these two shapes. So area of an equilateral triangle is side squared times the square root of 3/4. Area of a circle is pi r squared. Because it's a 5/6 circle, we're going to multiply by 5/6. And so we're just going to plug in the side length of the equilateral here. And then the radius of the circle here. And so if I compute this on my NSpire calculator, then we get an answer of about 118.9. So that'll be answer choice A. So that's a nice, fun geometry one. The next few questions are all going to be geometry related. Okay, question 15. Consider triangle ABC with a point D. Okay, so I always like to draw my, like whenever it says just draw a triangle, ABC, I like to make it scalene. So let's just say ABC. There's a point D on side AC. Okay, so just pick there. So if triangle ABC is 3 times as large as triangle ABD, okay, so what I'll do here is in orange, this is going to be triangle ABD, and ABC is the whole triangle. We're saying the whole triangle is 3 times as big as ABD. So if that's the case, then what's the ratio of the lengths of AD to DC? This is a nice question. Let me actually drag this. I'm going to rotate it. Can I rotate it? Doesn't look like I can. But, okay. So let me just kind of redraw this a little bit. Okay. So something like, whoa, something like that. Okay. So position like this, both triangles ABD and ABC have this same height, h. So that doesn't change. So that means if the area of ABC is 3 times greater than ABD, that means side length AC has to be 3 times greater than AD, right? So that'd be like if AD is like 1 and the whole length AC is 3. By consequence, that would mean like DC would be like 2. Okay. And so to get the ratio, we want the ratio of side AD to DC. That's going to be 1 to 2. And so that's going to be our answer, answer choice E. make sure you just read carefully, because you might think to do 1/3. But it's asking us to compare AD to CD instead of AD to the whole length AC. All right, the radius of a cone is increased by 2 inches. So the radius is increased by 2. And the slant height, so if we have a cone, this is our slant height, this is our radius. Okay, the slant height decreases by 3 inches, and the volume increases by 140. The original radius was half the original slant height. So we'll just say our original is equal to 1/2 the original slant height. So what's the surface area of the new cone? So I can write the expression 140 equals the new volume minus the old volume, right? Because that's the increase. So we'll say 140 equals, and so the new volume, okay, well first let's write the old volume actually. Old volume is going to be pi over 3 times r squared times, and so given the fact that the old slant height was double the radius, this becomes a 30, 60, 90 right triangle. So I can easily get my height to be r root 3. You can prove that by Pythagorean theorem. Okay, and so for the new volume, that's going to be pi over 3 times, so our new r is r plus 2, so that's squared. So that's pi over 3 times r squared times, well, the new height we need to calculate. That's going to be, you have to do Pythagorean theorem. So I'm actually going to write this down here. It's going to be a little big. So that's our slant height, original slant height minus 3 squared, because this is like the new slant height squared, minus the new r squared, which is r plus 2 squared. So this is the new height. So it comes pi r squared times h over 3. Okay, so now everything is in terms of r. And if you solve for r by typing this in your solver, or graphing it, you should get an r value of about 13.35. So we want to calculate the new surface area. So that's going to be pi r squared plus pi r slant height. This is the circle on the bottom of the cone, and this is the lateral surface area. Okay, again, we're talking about the new radius and new slant height. So if this was our old one, 13.35, our new radius is going to be 15.35. And so given our old slant height was double our radius, this would be like 26.7. Our new slant height would be 23.7. And then doing pi, well actually we don't need to do Pythagorean. Okay, we can just plug these values in now. So that's going to be pi times 15.35 squared, right, plus pi times 15.35 times 23.7. That comes out to about 1,883. So D is our answer choice. That's correct. Okay, so now, number 17. Okay, consider triangle ABC, just similar to triangle DF. So I just like to draw two almost equilateral triangles. Doesn't matter. Okay, so AB is 12. So it's just going to give me a bunch of details, and I'm going to just fill it out. C is 45 degrees, AC is 8, and EF is 9. Okay, so we want to know what the area of DEF is. Okay, so I got to find the ratio between these two triangles. So one way I can do that is I can do a reverse law of cosines here, right? So law of cosines says that if I call this side BCX, I could say 12 squared equals 8 squared plus x squared minus 2 times 8 times x times the cosine of 45 degrees. And I can solve for x. And so if I do that, what I end up with so I'll type this into my solver. I end up with a value of 16.24 as my x. And so here's what I can do. I can get the area of triangle ABC, and then using this factor of r, which is like the ratio between these two sides, I can just multiply the area of ABC times r squared to get my area of this triangle. I gotta multiply by the rate squared because like the rate compares like these one-dimensional things, which is like side to side. And so to compare these two-dimensional quantities, which are like area, I've gotta square that factor so that I can compare two 2D entities. So to get the area of ABC, I can do AB times sine of C in degrees. Actually, I don't think it matters. AB sine C over 2. This works for any triangle to get the area. So I'm going to just call this A and this B. So I'm going to do, we can get rid of that. 8 times 16.24 times the sine of 45 degrees over 2. And that area comes out to 45.93. Okay, so R, my rate, is just 9 over this value. So I'm going to multiply by r squared. I get my area for DF as 14.1. So that would be B. So that's my answer. Whoa. What happened here? Okay, that was weird. We're not done with the geometry questions just yet. Okay, we're going to do 18. Okay, so consider a circle with center O and chord ST. The length of the chord is 15. 15 units. And the shortest distance from the center of the circle to the chord, so this length, be perpendicular. That's 6. What's the area of the circle? Easy question. So we can get the radius of the circle immediately. If we half the side length, this is like 7.5 and 7.5. So I can just do Pythagorean to get r squared. The area is pi r squared. So again, r squared is going to be 6 squared plus 7.5 squared. The area is going to be pi r squared. I can just do pi times 6 squared plus 7.5 squared. And that comes out to 290. So answer choice C. So that's a pretty easy circular geometry question. Then 19. Okay, so Morty has a 3D printed vase for his mother's birthday, and the base of this vase is a hexagon with a circumradius of 4 inches. And like if I kind of change my view, so I'm looking down at the base, the circumradius is going to be like this length here. Because the inradius would be like the apothegm. Circumradius, it's going to be from the center of the circle to the one of the vertices. Oh, not 6. It's 4. Okay. So if the height is 15, how many cups of water can be filled? Okay, so let's first get the volume in cubic inches, and then we'll proceed from there. So volume of any pyramid, that's just going to be pi over 3 times, or no, my bad. It's always area of the base times height over 3. The area of the base is actually pretty easy to get. Because this is a hexagon, we can split it into 6 equilateral triangles. And when you look at that, the circumradius is equal to the length of one of these equilateral triangles. So we can just do the area of one equilateral triangle times 6, and that's the area of the whole hexagon. And then we'll multiply by, so that's the area of the base, multiply by the height, divide by 3, and that's our volume. So we get a value of about 207.846 cubic inches. All right. Okay, so here's a conversion you gotta know. You gotta know that 1 gallon is equal to 231 cubic inches. So if I divide our volume by 231, I get that we have 0.899, like 8998 gallons of water. And so I'll multiply by 4 to get how many quarts we have. And then I'll multiply by 2 to get the pints. And then 2 again to get how many cups we have. So from that, after typing it out, I'll get that we have oh, did I mess up? I might have messed up a little bit. Let's see, a volume of the base. or area of the base. Okay, that part's right. Should be how many gallons I have, times 4, quarts, and then pints, and cups. Oh, I know what I did wrong. This is not a cone. This is just a hexagonal prism. Okay, ignore that. Okay, so really, our volume should have been triple this. So it should have been this value. And then after dividing by 321, should get like 2.7 gallons. Then times 4 times 2 times 2, we get 43.2 as our cups. Yeah, so again, to recap, it's a hexagonal prism. We have the area of the base multiplied by the height. So that gave us our volume in cubic inches. And using this conversion, that 1 gallon is equal to 231 cubic inches. I divide by 231, we got 2.7 gallons. Multiply by 4 to get from gallons to quarts, then by 2 to get from quarts to pints, and then 2 again to get from pints to cups. Leaving us with 43.2 cups. All right, so number 20. Okay, so the center of a circle is in quadrant 2, and the circumference is this. Oh, I don't even think I need to draw this, actually. Okay, we want to know what the value for A is. Okay, so typically, when you write an equation in circular form, it's like x, I think it's called circular form. But typically, if you're trying to graph the equation of a circle, it looks something like this. And so our goal for this question is to kind of shape it to look like this. So we want to turn this equation to something that looks like that. Okay. Also, keep in mind that at the end, once we do this whole process, we want to end up with 100 on this side of the equal sign. Why? Well, because if our circumference is 20 pi, that means our radius has to be 10. Therefore, our r squared has to be 100. So keep that in mind as we're going through this question. Okay, so first thing I'm going to do, I'm going to move this 20 to the other side. So I end up with this as my expression. And then what you want to do here is you want to complete the square. So we're going to look at our x terms first. So I'm going to just rearrange it like this. So completing the square, if I do that, I would be adding 16 here to both sides. And then this turns into x plus 4 squared plus y squared plus ay equals 36. Okay, and then from there, if I complete the square for the y terms, that means I'm going to be adding a value of, remember, when you complete the square, you're going to add b over 2 squared. to both sides. So that means I'm going to add, this is my b term, I'm going to add a over 2 squared to both sides. And so why is this important? Well, because after this step, on this side, my equation should look like this. Like this should be the final form of this equation. Keep in mind, this side should equal 100. So that means that a over 2 squared equals 64. Therefore, a over 2 equals 8. Therefore, a is supposed to be it's supposed to be a over 2 equals plus or minus 8. My bad. Meaning that a is equal to plus or minus 16. All right. So the only answer choice that kind of conforms to one of these values is D. So that's our answer. But you could also like figure it out, like if, let's say, positive 16 was also an answer choice, then which one do you pick? Well, remember, this is supposed to be in quadrant 2. So the circle should be centered in the positive y. And so for that to happen, the a value has to be negative 16. Because remember, like to move something, it's like y minus k squared. If you want it to go to like some value comma k. So if I do y minus negative 16, it would give me like a value of positive 16. Okay, so that's going to be last question for now. So that's 20 questions. If you were to do all 20 and get them all right, that would be 120 points, which is a pretty good score. So yeah, I guess that's my walkthrough. The first third of this test. I'll go over the next 20 questions soon.